Well, I don't know, honey. That car's been parked there for a long time. Well, no, of course I didn't. I had Cinco de Mayo at the Jeffersons. Whoa, that's a mean-looking tennis player. Tennis player. Tennis player. Tennis player. Tennis player. Tennis player. Tennis player.
That was the song Squash Man by the squash-themed hardcore band The Eradicator. My name is Manuel Matuzović, and today I'm here to talk about color in CSS. And the reason why I picked this topic, color in CSS, is that I got really excited about color recently, and I shared my excitement online. I wrote, "It surprises me how excited I am by color theory. I find it hard to understand and learn, but super interesting. I can see myself digging into color on the web next year." And that's what I did. And to be honest, before that, I'd never really cared about color in general, and also color in CSS. But I was working on a new workshop with my friends at Smashing Magazine called the Advanced Modern CSS Masterclass. And in preparation for this workshop, I made a list of all the different properties and modules and terms that I wanted to teach people. And if you look at that list, you will see that there are many things that most people are really excited about, like container queries, nesting, scroll-driven animations, and my beloved has pseudo class, which is one of the most significant and important additions to CSS, if you ask me. And looking at this list, I also realized that many of these topics were related to color. And that made me curious, because these are only the recent additions, and I was wondering, what else is there we can do in CSS with color? So I went back 5 years, 10 years, even 20 years, and as it turns out, there's actually a lot that you can do with CSS, with color in CSS. And you know, of course, it makes sense, right? CSS is constantly evolving, and in 20 years, stuff happens, right? But when I had this list in front of me, I was surprised by how much there is and how little I was using. So my goal today is to get you as excited about color in CSS as I am, and also show you some of the new stuff that we can do. And to do that, we have to go back 25 years. Don't worry, I'm not going to take you down memory lane for the next 15 minutes, but we have to start where I built my very first website. Okay, before I show you the next slide, does anyone in this room speak French? Okay. I'm sorry. So, about 25 years ago, I played a game called Counter-Strike. I think it still exists. It's this online shooter that I played with my friends. And we had a group, a so-called clan, and for this clan I made a website, and that's what you see here. It's a 3-column layout. There's a background color and white text. In the first column, there is the navigation with some industrial-style, metallic-looking, inaccessible image buttons. And in the right column is some secondary content. In the middle column is the main content. And at the very top, it says "mange ta merde," which means "eat your poo." The thing is, like I said, I was 13 years old. We played this game, and we just started learning French in school. So of course, that was the name of our clan. What's special about this website, except for the name and the fact that it was optimized for a certain resolution, is that there is no CSS on this site. So of course, for the layout, I'm using highly inaccessible tables, table layouts. And for styling, I'm using presentational attributes like BG, color, text, and A-link, and so on. And what's special about this code that you see here, the body, start, and end tag, is that first of all, I'm using hex codes. And second of all, I'm using specific hex codes, because back then I was told that I could only use a subset of all the 16.7 million colors that RGB offered, the so-called web-safe colors. So there were only 216 colors that I could use, because back then screens couldn't display more than 256 colors. So if you wanted to make sure that your colors will be displayed correctly, then you would have to pick one of these. And by the way, it's 216 and not 256, because some were reserved for the operating system, and there was also a practical reason that doesn't matter right now. All right, so yeah, then my first big milestone was in 2006 when I finally learned CSS, and I was still doing the same things. I was applying hex values to properties in CSS now instead of HTML. And thankfully, the 256 color problem was gone, because screens got better, and now we could use all the colors in RGB. Another milestone was gradients, because before we had gradient functions. If you wanted a gradient, you would have to open an application like Photoshop, draw a gradient, change the canvas size or the width to 1 pixel, save that as an image. And then in your CSS, you find the element that you want to style, you reference the image, you make sure that you repeat it horizontally. And then you check, and then you need to apply some CSS Pro skills to fill the entire screen. And that's it, you got yourself a gradient. By the way, this is also how we did box shadows, a very similar technique before we had the box shadow property. I mean, it worked, it's fine, but it's of course not very dynamic. So yeah, of course, that was a big milestone for me, the linear gradient function in CSS. And that's it, at least for me, for the first 15 years or so of me writing CSS. I didn't do much more with color. That's it. Apply hex values and draw a gradient here and there. The only other thing that I was using was the RGB function, or actually the RGBA function, because as you already heard, it had this has this convenient feature of being able to add an alpha channel. But honestly, I never really understood how RGB is better than hex or RGBA, because I find both essentially unreadable. They're very developer unfriendly. For example, can you tell me which color this hex code represents? Is RGB better? It's the color you see, the color of the text, this dark pink, whatever it is. I don't know. I was in Hamburg last year for the Hamburg meetup, shout out to Leah. And my friend Marco told me that there is a colorblind designer named David DeSandro who can actually read hex codes and tell you which color they represent, even though they don't necessarily are able to perceive that color, which is mind-blowing. There is a talk from .css in 2018 by David DeSandro online. Check it out if you want. Yeah, so what I like much better than hex is HSL, because HSL is developer-friendly. It's readable. HSL takes 3 values. The first one is the hue. You define it by picking a value between 0 degrees and 360 degrees. Then you have the saturation, which you define in percentages from 0% to 100%, and the lightness also from 0% to 100%. And 0% means it's black, and 100% it's white. And if you know how the color wheel looks like, if you know that it starts at 0 degrees with red, and then it slowly turns yellow at 60 degrees, green at 120, then cyan, magenta, blue, and so on. If you remember that, you can read HSL. So if you look at that code, you know it's a green color at 120 degrees. It's a highly saturated color. It's intense. It's vivid because it's 100% saturated. And it's a dark color because it only has 10% lightness. So it's a dark, intense green. Here's another representation of HSL. So you can see there's this conic shape. In the circle, we pick the hue. Going from the inside out, we define the saturation. And going up and down, we define the lightness. And HSL is especially great if you're working with custom properties in CSS. So let's take this notification component, or as I like to call it, a div, that I built. I made a custom property for the background color and one for the border color, and I'm applying it for the respective properties. And this code is fine, right? But it can be improved because, as you can see, the hue is the same, the saturation is the same, and only the lightness is a bit different. So I create 3 more custom properties, one for the hue, one for the saturation, one for the lightness. We reuse the hue, reuse the saturation, and actually also reuse the lightness, with the difference that in the border color custom property, I use the calc function and subtract 20%. And this is really dynamic and flexible, and this is something that you can use to build a system. So if we need a variation or multiple variations of our components, then all we have to do is change the age, the hue custom property. And then we have different variations in different colors, which is really cool. So it sounds like HSL is perfect for color systems inside design systems, except that it isn't. There is a problem with HSL. It's kind of like tennis. It has some great ideas, some great features, but it sucks. And before I can explain why, we have to learn 2 new terms. The terms are gamut and color space. And I guess now is a good time to tell you that I'm not an expert in color theory. Like the things that I'm saying today are probably not 100% accurate, but it's good enough for you and me. It's fine. It should be okay. All right, so we start with gamut. The gamut defines the amount of colors or the range of colors, and a gamut can have a name like sRGB, for example, or display P3. What you see here, this triangle filled with color, is all the colors that we can access in sRGB. And then we have another shape, this gray shape, which represents the colors that we can actually perceive as human beings. So you can see the colors that we can use in sRGB is where the amount of colors is very limited, but there are actually way more we could see. And there are different gamuts, here represented using triangles. So the center triangle, the red one, is RGB. Then the next one in purple is display P3, and so on. And you can see how ProPhoto can display way, way more colors. Here's a different representation because someone told me last week that this slide sucked, so I added another slide. Here we can see sRGB, the sRGB gamut in the sRGB color space in this rectangular shape, and display P3 offers more colors, and then Rec 2020 and ProPhoto even more colors. So you can see how much more colors there are in these gamuts. So when we talk about the amount of colors or the range of colors, that's when we use the term gamut. So we can talk about a low range or a narrow gamut or a high range or a wide gamut. The next term we need to know is color spaces. And the color space is an arrangement of a gamut, and it also establishes a method of accessing colors. For example, there's the RGB color space. This is a little bit confusing because there is an RGB gamut and also a color space by the same name. And what RGB does is it creates this rectangular shape, and you can access colors using the R, G, and B channel. So that's what we're doing in hex and in the RGB function. There is another color space, HSL, which also uses the sRGB gamut, but it has a different shape. It has this cylindric shape and also a different method of accessing the colors using hue, saturation, and lightness. So we use the term color space to define an arrangement of colors and also methods of accessing colors, and also when we talk about interpolation, which we will do later today. So here's another cool demo because it looks professional. Here's a square with some named colors. And then we can display the same colors in a different color space like HSL, where we have this conic shape. So coming back to the problem with tennis and HSL, if we take the RGB color space, which is in a square shape, and we convert it to HSL, we get this conic shape. All right? And as long as we stay inside that shape when we use our combinations of hue, saturation, and lightness, we're fine. But if we use a combination that ends up somewhere outside of this shape, we have a problem. Because the thing with HSL is we can use any combination of hue, saturation, and lightness, even if there isn't a color that represents these numbers. And that's a problem. And a good way of dealing with that would be to find an algorithm that just picks the closest matching color for you automatically. So you use a combination, a color doesn't exist, you end up out of gamut. An algorithm recognizes that and just finds the closest number. Unfortunately, HSL is pretty old, and back then they weren't able to come up with a performant algorithm to do that. So what they did instead is they just filled the color space with white and black, white at the top and black at the bottom. So now you can't end up out of gamut because all hues have the same maximum values. But the problem is that they're artificially creating colors that don't match, colors that don't reflect human perception of lightness. They're just artificially mixing whites to colors and black to colors. And this can be a problem. And also, if we look at this circle, this color wheel in HSL, it's not a perfect circle like in the representations that I showed you, because there isn't the same amount of saturation for every hue. And this can be a really, really problem for us in CSS. It makes picking colors really unpredictable. If you look at this scale, what you can see here is different hues with the same amount of saturation and the same amount of lightness. And something is really, really wrong with that if you look closely. Can you see how the blues are really, really dark and the greens are really, really light? So the blue is much darker than the green, which shouldn't be the case because they have the same amount of saturation, the same amount of lightness. Only the hue is different. And that's the problem with HSL. Yeah, so according to the color model, this is uniform, but it definitely feels wrong for us as humans. And this is why we say that HSL is perceptually not uniform or ununiform. Here's an example in CSS. So we have two buttons, actual buttons, not divs. One says send and the other one says, very controversial, I know. One says send and the other one says save, and we want to create a variation for the save button with a different color, like a green color, for example. So if we go back to my notification component solution and we just take the same solution, all I would have to do now is just change the hue property to something close to 120 or so that we get a green button. And if I do that, we end up with this, which is really unexpected because I didn't change the saturation, I didn't change the lightness, I only changed the hue. But this green button is much, much brighter than a purple button. And this is where Lab comes into play. Lab was designed as a perceptually uniform color space. It takes human perception into account. Remember when I told you that I don't know much about color theory? I have no idea how they do that. They're scientists, I don't know, but they do it. Like they're able to take human perception into account. And what's cool about Lab is that it's also designed to cover the entire range of visible colors if the devices support that. There is a lightness component similar to HSL, defined with a term between 0% and 100%, and then we have A and B. And the A-axis is relative to the opponent's green and red, and the B-axis is relative to the opponent's blue and yellow. And it's not just great because it's perceptually uniform, it also uses the display P3 gamut. So not RGB anymore, but display P3, which means we have 50% more colors. Remember the triangles that I showed you? The purple triangle was a bit larger. It's actually a lot larger, like 50% larger. So we have way, way, way more colors that we can use. The only thing that I don't like about Lab is, again, we're mixing colors. We have the lightness component, but you have to mix, I don't know, red with blue, which just doesn't work for my brain. Luckily, there is LCH. So just as HSL is an easier to use representation, a cylindrical representation of RGB, LCH is an easier to use cylindrical representation of Lab. We have a lightness component, a chroma component, which is relative saturation, and also a hue. And yeah, you can see how it's in this cylindrical shape, very similar to HSL, but it doesn't actually artificially fill it up with black and white. It's just like it is. And that's because instead of artificially creating colors, what Lab does is if a color is out of gamut, it tries to find a better alternative that somehow matches this combination that you were using. According to the spec, the best way to do that is to use a hue-preserving and lightness-preserving algorithm. Unfortunately, that's not what browsers implemented. They're using a naive clipping technique. So if you use a combination that exceeds the RGB values, they just clip it, and then they give you a color. And that can yield very unexpected results. Here's a demo to illustrate that. We have a couple of rows here. In the very first row, I'm using the combination 90% lightness, 15% chroma, and 0 degrees. And it gives us this light pink color, which is fine. And this color is still in gamut. If if I increase the 15% to 16%, we are out of gamut, but the color still looks the same, so that's fine. If I change to 17, 18, 19, 20%, we're still fine. We're out of gamut, but it's okay. The color still looks the same. But if you increase that number to 20%, 40%, 60, 80, you can see how we get a completely different color. So if you use a combination that ends up wide out of gamut, you may get a different color, which is bad. Here's a demo by Miriam Suzanne. You have a comparison here. On the left, you see how color is implemented in the browser today. On the right, you see, I guess it's color.js, so some JavaScript library for managing colors. And what Miriam did here is she defined a hue of 242, a chroma of 50, and in this scale here, you can see a transition from 100% lightness to 0% lightness. And if you remember at the beginning, I told you that 100% means white. But on the left here, you don't see white. You see a light blue color. And 0 means black, but you don't see black here. You only see a dark blue. So this gradient, or this transition doesn't really look nice. Here we have an implementation according to spec, and you can see how it starts at white and it ends at black. And this is much better and much nicer, and much more expected. There's a GitHub issue with, as you can see, a lot of participants, a lot of posts, a lot of opinions. So if you want to have a bad day, read that. There is an ongoing discussion. I think last week Miriam asked about the current status, and I haven't seen a reply yet, I think. All right, so if HSL is tennis, then LCH and LAB are curling. They're great, but they're just not the sport for me. That's because there is a bug in lab and LCH. Who knew that there can be bugs in color spaces? But yeah, it is what it is. And here we see that bug. So at the tip of this triangle, you can see a blue color. And if we transition from the blue color to white, we would expect that the blue just gets lighter. And if we transition from the blue to the black, that it gets darker. But what happens is it gets lighter and darker, but it also turns purple. And that's because there is an unexpected hue shift towards purple between the hue values 270 and 330 in lab and LCH. So that's a bug. And yeah, that's also not great. And this is why Björn Ottosson came up with a new color space, which is similarly awesome as lab and LCH, but one that is simple to use and also does a good job of predicting lightness and so on, and also one that fixes this bug. And that's what we want. Now you can see a nice transition from blue to white without any shifts towards purple. And this space is called OK Lab and OK LCH. Why? Well, according to the paper that Björn wrote, it's called the OK Lab color space because it's an OK Lab color space. It's just an OK implementation of lab and LCH. I absolutely loved it. One of my favorite things. Here's a tool by Adam Argyle. It is just a color mixer, so the two rectangles at the top are color pickers. We have blue and white, and we are now mixing it in the lab color space. And I'm changing the lightness, and you can see how it turns purple, which we don't want. And if I change that to OK Lab, it looks okay. So for you, that means that for most of your CSS, you probably want to use OK Lab or OK LCH. We have dedicated functions for that. We have the LCH, the LAB, and also OK LCH and OK Lab functions. And the numbers here look like arbitrary magic numbers because they kind of are. I don't know what's going on here. Like in OK LCH, we have the lightness component, which we understand, 0%, 100%. But then for chroma, for the saturation, we have a value between 0 and 0.37. And then we have the hue, and for lab, we have the same lightness, and for A and B, we have values between minus 0.4 and plus 0.4. Yeah, absolutely random. Luckily, the Evil Martians crew built OKLCH.com with a really great color picker, where you can just pick your colors. You can also just paste a hex value, for example, and they will convert it for you to OKLCH or OKLab. And if you look closely at these range sliders, you can see how there are some gaps. And this is when you move the thumb into one of these white areas, it means that you pick the color that is out of gamut. So it also shows you if you're in gamuts. It's a really cool tool. There's also a 3D representation for people smarter than me. So that's definitely something you want to check out. So if we go back to our example, if you remember, we got this really horrible light green button with HSL. If we do the same with LCH, we get a button or a color that harmonizes with the purple color. And you may have noticed that I'm using spaces here in those functions. Josh also mentioned that. There is a space-separated functional color notation that we can use with traditional functions like RGB. So you can, instead of using commas in RGB, you can use spaces, which allows you to add an alpha channel. And with OKLCH and OKLab and all the new functions, we have to use the space-separated notation. So no commas in those functions. Cool. So we have dedicated functions for lab and LCH and OKLab and OKLCH. But what if you wanted to use another color space, like RGB without gamma correction, for example, gamma correction? Then you can use the color function. It takes up to 5 values. The first value is the color space that you want to use, for example, sRGB linear. Then you have 3 channels, R, G, and B, represented by numbers between 0 and 1, or 0% and 100%, and an optional alpha channel. And of course, you can only do that with non-polar color spaces, so that doesn't work with HSL or LCH. Important thing is, just because you can use the value rec 2020 doesn't mean that you can display a color in that color space, because your device and browser may not support that. If you want to be really safe, you can use a media feature, the color gamut media feature, and there are 2 values, P3, which stands for a wide gamut, like this P3, and then there's rec 2020, which stands for a really wide gamut. The names that they picked here are really unfortunate, because rec 2020 doesn't necessarily stand for rec 2020, but generally for a really wide gamut. So yeah. What's cool about having different color spaces isn't just the fact that we can access more colors, but like I said, in different color spaces, colors are arranged differently, which can also yield different results when you're creating gradients. And this is one of the coolest things with these color spaces. So let's say we have a linear gradient from left to right and from hot pink to aqua. What we can do now is we can say, you know what, give me that gradient, but please don't use the RGB default, use OKLab for the gradient. And this will give you a different result. So we can compare the same gradient in RGB, OKLab, and OKLCH. You can see how OKLab will give you a very different result than RGB, for example. OKLCH looks very similar to RGB, but the colors are more vibrant. The gradient is nicer. It probably also looks better on my laptop screen than on this screen, but it gives you very, very saturated colors. So you may want to use OKLCH for gradients. But you don't necessarily have to. You could also try other color spaces and see if they yield different results that you may prefer. Another really cool thing is about color spaces and hue interpolation, that by default, a gradient will take the shortest route. So if we have color A and B, so the first circle here and the second circle, it will always take the shortest route on the color wheel to create the gradient. And we can now influence that. We can say, you know what, take either the shorter hue or the longer hue on the color wheel, so it doesn't go the shorter route, but the other way around. And then the same combination of colors will give us completely different gradients. And having access to color spaces isn't just useful for gradients, but also for color mixing. We can mix colors in different color spaces. We have 3 values with the color mix function. We define the color space that we want to mix in, and then the first and the second color. And this will give us this result. Okay, no reaction. You know what? Last year I was at Beyond Tellerrand, and the day before I was there with my kids, so I didn't sleep at all. It was 10 p.m. the day before, and I was like, okay, how do I visualize the mixing of colors? Of course, a bouncing squash ball. People will love that, but it's the 4th time I'm giving this presentation. No one appreciates my squash balls. Okay. Thank you. That's what I want to do. You can also specify the amount of colors that you want to mix. You can say, give me 70% hot pink and 30% aqua. You can actually just define 70%. It will automatically use 30% for the other color. And if your combination of values doesn't add up to 100%, it will take the remaining percentages and apply them as an alpha value. This is why this squash ball looks so washed out. And if you mix colors in different color spaces, it can yield very, very different results. So in all these examples, I'm mixing hot pink and aqua with the same amount, 50%. And that was so confusing for me when I got started with that. Like I was like, hey, let's see what color mixing does for me. And then I got so completely different results. Like this looks almost gray, and then we have purple and blue and something that goes towards green even, maybe. And then I realized the best way to deal with that is just to accept it. It's just what it is. No, it's a feature. It's a really great thing. So you want to mix colors, you just try out different color spaces. It's just something that you can use. It's a tool, it's a feature, it's great. It's perfect. Again, Adam Argyle's tool where you can do some testing. So you take one color and another color, and then you mix it in different color spaces, and you can also change the lightness. It's on CodePen, it's in the slides. All right, so what if we can't pick color spaces? What if we are working with, I don't know, a third party that provides us with boring old hex codes? Relative color syntax, another incredibly awesome addition to CSS, probably on the same level with the has pseudo class for me. And here's what you can do. You can say, you know what, give me that hex code, but please represent it in LCH. So we're taking from the color that we have, the color that we're provided with, we're taking the L, C, and H channels, and we're using it in the OKLCH function. And what's really awesome about that, of course, you can put the color into a custom property. We can actually manipulate the channels. We can say, you know what, take the lightness from this color, take the saturation, but use a different hue. And of course, we can also use the calc function, so we can say, you know what, take the lightness, but subtract 20%, for example. And you can also do something like that. So you don't necessarily have to use the channel in its respective place. You can combine them. I'm not going to pretend that I understand what's going on here. I copied it from the spec. So if we go back to my very first example, the notification component, if we wanted to write that with the relative color syntax, we have to think differently. We have to challenge the way we approach CSS a little bit. And that's what I like a lot about many of the new things that we have in CSS now. It challenges us to completely change the way we approach CSS compared to how we used to. So here's how I did it. Maybe there are better ways, but first I define a base color. This is the blue color for this default state of my component. And then I say, based on that color, give me two variations. So I'm reusing the lightness and the chroma, and I'm only changing the hue because I want a yellow and a red variation. Then I have this private custom property, which isn't a thing, it's made up, but I'm using an underscore to tell me and my colleagues this is a custom property that we are only using inside the component. It's not supposed to be exposed to the outside. And we say, if someone provides a color, take that color. If there is no color provided, just fall back to the info color. And we use that color for the background, and for the border, we change the lightness and the chroma a little bit and take the hue, and that's it. And now we can do the same thing in a very, very flexible way, in very dynamic and powerful way for color systems. Cool. Another exciting addition to CSS are color fonts. I didn't know those existed. Here is a random arrangement of randomly picked letters. And if you look at that example, at first it doesn't look too special, but you may realize, hey, there are multiple colors here. There isn't just one color for this text, but actually 4 colors. And yeah, that's what color fonts are about. They can display colors, first of all, by default, and also multiple colors, which is really cool. And they also come with different palettes, so with different sets of colors. So for example, this font here. This font here comes with 11 palettes. And we have access to them in CSS. Yeah, make your photos. That's a good one to share. The last one I put in for you. There is the add font palette values add rule where you define the font palette. You have to define a name using this -- syntax. There is a proper name for that, but I can't remember it now. I have to ask Primus later. There is the font family that you have to define, and then you say which palette you want. It starts at 0, so it's 0 based. If you want the first one, the default one, you would define 0, and then you can define a number. And then at the very bottom, on line 17, you can see how I reference the palettes, the custom value. Okay, it's a custom ident. It's a custom ident. Okay, you just use the -- syntax. Browser people arguing. I guess font palettes, the font palette property, and then you reference this palette that you created. Now the question is, how do I know which palettes a font gives me? Well, you can use the Wacom Fondue website, which is such a great name and also such a great design. It's about fonts, but it doesn't look like it's about fonts. And what you do here is to drop a font, and this is built by Roel Nieskens, by the way. It will tell you all kinds of things about your font, like how many glyphs there are and the size, and all kinds of interesting features. And it also lists the different palettes. So you know which palettes there are, and also the access, by the way, if it's a variable font. You can also override colors, so you can say, you know what, give me the 9th or the 10th palettes, but I don't like the last color. So you can use the overrides color property, which expects a list of 2 values. The first value is the color you want to change, starting at 0 again, and the second value is the color. And of course, if you wanted to create a custom palette, you just replace all the colors, and this will give you another one, another combination. Then there is color schemes, which is another exciting thing. We already heard about that today, so I just removed all the slides. You know everything you need to know by Nia, thank you. That's talking for me. One thing that I can point you to is this article by Joy, who will speak today as well, Come to the Light Dark Side, which is very extensive and goes into all the detail about this topic. And that's it for me. Okay, I probably have to explain that. As you can hear, I'm not a native speaker, so I went on iStock Photo and all kinds of stock photo sites, and I searched for squash. And I got some squash, like the game, and then I got this, and I was like, what's going on? There's something broke. Yeah, then I pulled out the dictionary and was like, oh, okay, that's also a squash, cool. If you're wondering why squash, why I picked the topic squash, and why I showed the video, there's absolutely no reason. It's completely random. One night I woke up and was like, you know what would be really cool if I would just play that video at a conference in front of, I don't know, 500 people. And then a couple of months later, Mark wrote me and said, hey, do you want to speak? And I was like, yeah, I already have something that I can use. Yeah, so that's it. Of course, there's more. I actually also had some more stuff in my slides, but I only have 40 minutes today. What I'm asking you to do now is to take that stuff and do some experimenting, because color in CSS is really exciting, but you don't see people write too much about it. So take some of that stuff that you learned today maybe and try it out, create some demos, write some blog posts. I want to see what you can come up with. And yeah, that's it. Thank you so much.